So this is quite tricky because usually what we're doing is we're trying to work out the final speed or the final gravitational energy. And there's a number of little tricks they've got in here. One of them, the mass is in grams, so we've got to convert it into kilograms. The height is in centimeters, so we've got to turn it into meters, and that's in grams too. So there's one little trick. Another really nasty trick is that the gravitational energy is going to be the gravitational energy of the box and the rock together. So let's just let's just solve some of these problems so we don't come across, so they don't cause us issues later on. 20 centimeters is 0.2 meters. 100 grams is 0.1 kilograms, and 20 grams is 0.02 kilograms. And so from then on, we can just think about it in terms of meters and meters and kilograms, okay? Because those are the standard units we must be using. So we can now work out the gravitational energy of the box and the stone together. So it's going to be equal to m. So it's going to be 0.1 plus 0.02, so 0.12 times g, which is in this called 9.8, times the height, which is 0.2. So that'll give us the final gravitational energy. So let's work that out. So that is 0.2352. Okay, that's a weird 3, but never mind. So that's how many joules of gravitational energy it has, or it has at the end of the transfer. So that means it must have had that much kinetic energy to start off with. And again, don't forget the trick that beforehand it was the gravitational energy of the box and the stone together, but the kinetic energy is just of the stone. So the kinetic energy of just the stone is equal to 0.2352 joules, and that's equal to half times the mass of the stone, 0.02 times its velocity squared. This is looking really good because the velocity is the thing that we need to know, and we've got everything else in the equation now. So we can now go the velocity. Let's say the velocity squared is equal to 2 times 0.2352. Then we would divide it by 0.02. That would be the velocity squared. So then if we square root both sides, then that would give us our velocity. Okay? And that's the answer to the question. So the trick was, don't forget that the gravitational energy included both masses, whereas the kinetic energy included just the one mass, the mass of the stone, and also to convert the units into standard units. All right.